Okay, Assalamualaikum and a very good evening. My name is Muhammad Ani Ahikal bin Khairuzam. My metric number is CN220604. Okay, today I want to present about the project overview of fluid mechanic leaf load. The reason of this project overview is the purpose of this project is to investigate the fundamental of fluid mechanics with an emphasis and on the idea of lift and how it affect load. The area of physics known fluid mechanics studies how liquid and gases react as well as the process as the forces that act on them. Okay, for the second slide shown my teammates or my group team members, which is the first one is me, Muhammad Anil Kamiruzam, and the second one is Khalis Rifai, and the third one is Shazan Nur Iman, and the fourth one is Alisha Imaira.
Hi, Assalamualaikum. My name is Nur Alisha Imaira. My matrix number is CN220280. So, I will be presenting about introduction. Hydraulic lift is a type of machine that uses a hydraulic cylinder to lift and lower objects by applying relatively small force compared to the weight of the object to be lifted. Hydraulic is the study of liquid and their mechanical properties, for example, how it moves, resists movement, and react when subject to pressure. In engineering, one application of hydraulic is using liquid like water or oil to move things. Next, there are some important parts of a hydraulic lift include piston and cylinder, hydraulic fluid, and control mechanism and valve.
Okay, okay. The problem statement that involve the fluid mechanic lift load for the first point is to build a prototype lift load that capable to lifting a minimum of 50 grams, which is Dr. Izwan said minimum of 50 gram. It can hold the load can the load can hold the prototype. If you can more than 50 gram, it will be a good. Okay, the second one is to fulfill with the leaf load specification, which state that it must not exceed one length, 1 meter in width and 1 meter in height, which is the dimension of the prototype leaf load. Okay, the third one is to create a heavy duty loading bearing that is solid and dependable. Okay, the main objective of this fluid mechanic lift load, the first objective is creating an efficient and successful structure is the aim of the strategic design. It can be used on the prototypes to make sure the concept of the implemented correctly. Okay, the second one is using the formula based on fluid mechanics course to determine a calculation and solution, which is one have style uh, build a prototype that relate to our course or subject, which is fluid mechanic, and make the prototype going well.
Hello and Assalamualaikum. My name is Shazanul Iman Beshamri and my matrix number is DN220087. So today I will present about the literature review. So before we start, we want to explain about the fluid mechanic. Fluid mechanic is a study the interact between force, movement, and statical state in a continuous mediums. So fluid mechanic is more focused there in gas and water. Next is about Pascal principle or Pascal law. That this is a principle that we use in our project. So this principle is explain about the pressure change in a component of a fluid at rest. It will be transferred without loss to every section of the fluid and the container wall. So this explain is if we give one force, and he can transfer the same value of force. So the formula in a Pascal principle is about P equal to F over A, uh, or F equal to PA. So for the explanation about the transfer force transfer in the same value, is a F1 equal to F2. So that means is P1 A1 equal to P2 A2. So the application of use this Pascal principle is about the usually used in hydraulic equipment such as hydraulic pressure or brake and hydraulic jack.
Next is material use and the total cost under methodology. These are the three most important things that we use for the project. As we can see here, this is our final look prototype for our project. We put a load which is a bottle of mineral water on it.
Okay, Assalamualaikum and good evening. My name is Muhammad Khalis Rifai bin Kamaruzaman and I will explain to you guys for the result. Okay. First, we must determine the area of each syringe piston. Okay. For our team, we use two size of syringe, which is 10 milliliter syringe and 20 milliliter syringe. Okay, first uh, we have found out that the diameter for the 10 milliliter syringe was 13.5 millimeters, and then to get the radius, which is we divide the diameter by 2, and we will get the radius for the 10 milliliter syringe, which is 6.75 millimeters. Okay, then we must convert the radius to meters, which is we use 6.75 times 10 to the power of 3, and then we will get 0.00675 meters. Okay, after we get the radius, then we can calculate the area. Okay, for our case, we use the area of circle because the range is a shape a circle. Okay, for the area, we use pi r squared, and then we will get the answer, which is 0.0000143 meters squared. Okay. For the 20 milliliter syringe, the step is similar to the 10 milliliter syringe, which is first we must find out the radius, and then we must convert the radius to meters, and then we use the same formula, which is pi r squared, to get the area for the 20 milliliter syringe. Okay, after we get the area for both syringe, we must calculate the force exerted by the 10 milliliter syringe. Okay, the force is calculated as F equal to mass times gravity. Uh, okay. So for a 1 kilogram load, the force that we get is 9.81 Newton. Okay. For the third step, we must apply the Pascal's law to find the force required for the 20 milliliter syringe. Okay, as we know, according to Pascal's law, P is equals to force over area is constant, which is we can make F uh, for 20 milliliter over A for 20 milliliter is the same as the force on 10 milliliter over the area on 10 milliliter. So after we get this equation, we must rearrange the equation, okay, to get the force required on the 20 milliliter syringe. Okay, for our team, the force that we get is 19.48 Newton. Okay, it means that 19.48 Newton is force is required to lift the 20 milliliter syringe. Okay, that's all from me for result.
Bypassing the connecting wire component or using a short wire, so it make the energy can transfer fast. Second is about change to push, and the third is about modify the material or adding a beam for strengths of the prototypes. And four is connected to the use of shrink of various size similar to hydraulic machine. This is because we want to apply the application of hydraulic.
Okay, for conclusion, there are 3 points that I have pinned out from our conclusion. Okay, for the first point, uh, it is area for improvement. Okay, area for improvement also include the integration of a bypass for the connecting wire components. Okay, for our team, the doctor recommend us using a shorter wire to minimize the force loss during the energy transfer. Okay, for the second point, which is structural enhancement. Our prototype structural integrity, especially its inability to withstand heavier weights, has emerged as a concern for us. So for this problem, we have come up with the recommendation of modifying the material to increase the toughness or introducing a reinforcing beam to enhance overall strength. Okay, for our third point, which is shrink size and efficiency. Okay, it also revealed a correlation between a shrink size and prototype efficiency, which is akin to hydraulic machines. Okay, that's all from us. That's all from me. Thank you.